Lesson 4 is performing operations with irrational numbers, and before we get into the operations, we want to compare rational numbers with irrational numbers. So rational numbers are on the left side of the page under that blue header, and this first section goes with 4.1 or the 4.1 workbook. So kind of the definition of rational numbers is any number that can be written as a fraction, which sounds like pretty vague. But there are kind of a few different like subcategories that we can look at. So for rational numbers, it includes all integers, which are basically the positive and negative numbers that don't have decimals. So say like -3, -2, -1, 0, 1, 2, and 3. Those are all integers, and this list keeps going in both directions. So like down to -4, up to +4, and so on. And then the next on the list, of course, like all fractions can be written as fractions, so they fall under the rational numbers category. For repeating decimals, they can also be written as a fraction. So for example, if I have 0.3 repeated, that is equivalent to 1/3. And that's the case for any repeating decimal. They can always be written as a fraction. And then for the next one, for terminating decimals just means decimals that end. So basically they don't continue on forever. And all terminating decimals can also be written as a fraction. For example, if I had like 0.14, that's equivalent to 14 hundredths. And you would even like technically read the decimal that way most of the time as 14 hundredths because it's in the hundredths place. Okay, and then moving on to the right side, the irrational numbers. So irrational numbers are the opposite. They cannot be written as a fraction. So the only or I guess the main types of numbers that cannot be written as a fraction are decimals that don't repeat and don't end. So the opposite of rational. So for an example, I could do 4.63298 and so on. It continues on forever, and there's no recognizable pattern. It just keeps going without any sort of repeating or anything like that. Another really popular example of an irrational number is pi, which pi is a decimal that goes on forever. Technically, I know we use a symbol to represent it, but pi is just 3.14159 and so on. It keeps going forever and it does not repeat. So that would also be an irrational number. And then another common irrational number that you'll see are square roots with numbers inside that are not actually perfect squares. So for example, the square root of 2 is irrational because I can't actually take the square root of 2. It just gives me a decimal that goes on forever. So I'm going to try to go split screen with a calculator. There we go. Okay, I've never done this before, so sometimes it'll probably get in the way. But if I take the square root of 2 and I plug it into the calculator, and you can use one on your phone, or this is I just Googled calculator and it popped up. I have to click over to f of x, it's for function, and put up the square root symbol, and then back to my numbers, input 2 in, and then if I take the square root or push enter or equals, I end up with a decimal that never repeats and never ends. So it kind of just proves that it's irrational. So if I were to try the same thing and say take the square root of 3, that's not a perfect square, so that should also be irrational, which it is. If I keep going and I take the square root of 4, that one I shouldn't get a decimal that goes on forever, right? I should get 2. And that's because that number is rational. Instead of having a decimal that goes on forever, it just stops at 2. Okay, and then the next section. So checking to see if a square root is rational, and this is with a calculator as well, so I'm just going to leave this up here. It's probably going to be up here for the majority of the time. I can kind of move it up if you are still writing the rational part. So if you need the part in the upper right corner, I would just pause the video and then play it once you're ready. Okay, so checking to see if a square root is rational. So we're just using a calculator to do this. I expect you to use a calculator as well. So I'm going to get my little radical, and then I'm going to enter this number 1.0609. And when I look at that, like this definitely looks like it's gonna be irrational because I have like a crazy decimal inside my radical. I feel like there's no way that's a perfect square. But in order to check, I'll do 1.0609. And then if I press enter, I just get 1.03. So I definitely get a decimal that ends, it doesn't repeat forever. So it actually means that like this whole number, like including the radical as well, is rational because it gave me like an answer, a simplified answer essentially, that was a decimal that ended. And then if I try the second one, if I try the square root of 170, so set up my radical and then 170, that gives me a decimal that goes on forever. So that whole number, like including the radical, is irrational. So 13.0384. I'm gonna go 048 and then just do a little bit of like a rounding review. So let's say I wanted to round to 6 decimal places, so I wanted to round to that 4 decimal like kind of spot. I would have to look at the number after it, so I'd have to look at the 8, and if that number in that place is 5 or greater, it rounds this number up, so I'd have to round that 4 up to a 5. So I'm going to round it to 13.038405, and it just kind of depends on what the workbooks or the checkpoints ask you to round to. It'll vary. Okay, the next one, adding with irrational numbers. So this whole section is pretty calculator heavy. I don't really like it because I like kind of like doing each individual step, and this feels like a lot of plugging in, but it's not too bad. So for example 1, it's 3 plus the square root of 7. And I just want to go through and kind of practice like identifying what is rational and what is irrational. So remember for rational, like I just needed to write it as a fraction, or I know that like integers were included. So this 3 would be rational. And then for the square root of 7, that one, because I can't take the square root of 7 and get like an even number out, 7 is not a perfect square, that one's irrational. So now I'm just going to go ahead and get an approximation for the square root of 7. So I'll go to my calculator, get my radical up there, and then type in 7 for the square root of 7. And then I think the workbooks ask you to round to 8 decimal places, so that's what I'm going to do for the rest of the problems. So the square root of 7 is about 2.64 and so on. So plus 2.6457513. I think I need one more decimal place, so the 1. And the like next number up is a 1, so I don't need to round my 8th place up or anything like that. And then now I just need to go ahead and add them. So this 3 is in the 1 place and this 2 is in the 1's place, so we just have to kind of technically add those together. If you want, if it's helpful for you, you can always like kind of rewrite the problem in a more vertical format, lining up the place values. So for example, the 3 is in the 1's place, so it would go down here. And then I can just add from like kind of, I guess technically right to left, but in this case, I think left to right works perfectly fine too because we don't have to carry anything. So we're just adding, making sure they stay in the same place. So it's 3 plus 2, 5, plus 6, 4, 5, 7, 5, 1, 3. And if there was like more place values, you would definitely want to start like from the left side over in case you needed to carry anything. Okay, so example 2. I was hoping I would be able to move that to the other side. I'm just going to go ahead and zoom in on example 2, just because I can't really move this calculator that well. So the square root of 5 plus the square root of 2, let's kind of identify what's irrational and what's rational, if anything. So for the square root of 5, it can't be simplified, like 5 is not a perfect square, so that one's irrational. And then the square root of 2 is also irrational because I can't take the square root of 2 either without, I guess, getting a decimal that goes on forever, aka an irrational number. So now I'm going to go ahead and add them together. So one thing that's really, really important is specifically when you're adding, you can't just like add the numbers inside of the radical. Like this would not become the square root of 7 ever. So don't try to avoid ever doing that. We're just going to go ahead and get a decimal approximation now. So I'll find the square root of 5. So the square root of 5, 2.23, and so on. Round to 8 decimal places, so 2.23606797775. I'm just going to write the whole thing and then worry about rounding it after. So it says to round to 8 decimal places, so this is my 8th decimal place, so I need to look at my 9th place, and that 7 would round this one up to an 8. So it's going to be 2.2360679. Sorry for so many decimal places, that's just what the workbook's asking for, so I want to stay consistent. And then now we just have to do the same thing with the square root of 2. So we found the square root of 5, now we need to find the square root of 2. Okay, so plus 1.4142135627. And then hopefully I didn't miss any decimal places. I'm gonna just round to the 8th place again. So that 6 is in the 8th place. I would look at the 9th place, the 2, and that number is like less than 5, so I don't need to round up. I'm just gonna cut it off after the 6, so it'll be 1.41421356. And then from there, I think if you want, you can just kind of use a calculator to add these two together. So from here to here, I do just kind of want to review like adding if we were to stack them and get the place values and stuff like that. So instead of rewriting this directly down here, I'm going to write it underneath the 2.23 and so on. So I'm adding them, so it'll be 1.41421356. And I would say like 9 times out of 10, you'll probably use a calculator for something like this, but it doesn't hurt just to kind of review things. So when we add like this, we need to start on the far right side. So first I'll do 8 plus 6, which is 14, and then I have to carry the 1. And then next I have the 9 plus another 1 plus 5 is 15. And then I have to carry a 1 again. So I have 1 plus 7, which is 8. And then plus 3 is 11. Carry the 1 again. 1 plus 6 plus 1 is 8. Don't have to carry a 1 that time. 0 plus 2, 2. Don't have to carry a 1. I do need to shrink my highlighter though because everything's too close together. 6 and 4 is 10, so 0, carry the 1. And then 1 plus 3 is 4, plus 1 is 5. And then 2 and 4 is 6. Don't need to carry anything. Need to bring down the decimal place. And then just add the 2 and the 1 to get 3. So all together, 3.65028.154. It's probably been a while since you guys have had to add that many place values, but it doesn't hurt to review a little bit. In the future, you can use a calculator. Okay, so the next section goes along with 4.2, which is multiplying irrational numbers. Those last one was adding them. So if we look at example 1, it's 3 times the square root of 2. So honestly, like, if you want, you can totally plug this whole thing in the calculator, but you definitely need to know how to do it. So I'm going to show you on this one. So I can just do 3 and then times. I don't think you technically have to type in the times if you're just typing the radical next, but it's better safe than sorry. So 3 times the square root, so hit the radical of 2 and then enter. So it is 4.24264068712, and then I'm going to round to 8 decimal places. So this is my 8th place, so I have to look at my 9th place, and then the 7 rounds this up to a 9. So it would be 4 times 2, 4, 2, 6, 4, 0, 6, 9. And then for example 2, I want to show you a couple different kind of ways to do it depending on what like calculator you have. So example 2 is the square root of 8 times the square root of 7. So on this calculator, it is like perfectly kind of like it works out okay because we can use parentheses. But if you're using, I know that like specifically the iPhone calculator makes it really difficult to do this as like kind of one step. So I'll show you on this calculator. We can do the square root of 8. And then you have to make sure that you hit the close parentheses button, which on mine is kind of at the top row, before hitting the multiplication button. And then times, we'd hit the radical again, and then the square root of 7. And we don't have to close the parentheses at the end. You can if you want to, but if you leave it off, it doesn't impact your final answer. And then when you're ready, click enter. So we end up with 7.48331473. I think that was my 9 decimal places. So now we just need to make sure we round it to 8. So this is my 8th place, and then this is my 9th place. So that 3 doesn't round the 7 up or anything because it's less than 5. So I just have to cut it off at the after the 7 to make sure I round to 8 places. So 7.4833147. And then there is a different way of approaching this if you kind of like if you test this out on your calculator and you're not getting the same answer, then it's probably pretty difficult to type it in just like with parentheses and stuff like that. So the other approach, I guess, is if you have two different radicals that are being multiplied together, you can technically multiply the numbers inside of the radical and end up with the same answer. So for like the square root of 8 times the square root of 7, I'm just going to multiply 7 and 8. And again, this is just another approach of the same problem. So 7 times 8 is 56, so this would become the square root of 56. And then we can even just kind of check it. If I were to find the square root of 56 in my calculator, so square root 56, I end up with the same exact answer. So it's that 7.4833 and so on. So either way works and you end up with the same answer. You just have to make sure that you round correctly at the end. I did kind of notice in the workbooks they tell you not to do this, but I'm not exactly sure why. As long as you round correctly at the end, it's the same exact answer. So honestly, whatever you prefer. And then just keep in mind that's there as a backup if you're having a difficult time getting the correct answer with your calculator. Okay, and then one more note. Down at the bottom, just a rule. Says the product of a rational number and irrational number is always irrational when the rational number is not 0. So just to kind of put some numbers to that situation, if you have like say the square root of 3 and then times, I forgot my rational number, but times the square root of 7. So 7 is rational. And then the square root of 3, of course, is irrational. So no matter what, if I multiply those together, I'll always get an irrational number, and you can always test it out with the calculator and stuff. This second part, when it says when the rational number is not 0, it's because if I were to make my like rational number 0, say it's 0 times the square root of 3, this time, well, anything times 0 is 0, so 0 is not irrational because it's not a decimal that goes on forever. So that's the only case that would make it irrational, is if you're multiplying by 0, because that makes everything 0.